Hi student, in today's lecture we will study the significance of concept of degree of unsaturation. This concept is basically used for determination of various possible structural formula for a given molecular formula. Degree of unsaturation provide an idea of types of bonding in the organic compounds like multiple bond or rings, etc. Again, to find out degree of unsaturation, a given organic compound first of all should be converted to an hydrocarbon. To convert it to an hydrocarbon, just remove the oxygen atom, nothing add and subtract along with oxygen. For nitrogen, we have to subtract hydrogen equal to nitrogen along with nitrogen atoms. For halogen, we have to add halogen atoms. We have to add hydrogen atoms for every halogen atoms removed. For halogen, we have to add hydrogen atoms for every halogen atoms removed. For charge, we have to add hydrogen equal to the magnitude of charge, positive or negative, whatever charge is there. We have to add hydrogen equal to the magnitude of charge. And after getting the corresponding hydrocarbon, now convert it to the corresponding alkane. To find out the formula of corresponding alkane, just see the number of carbon atom in corresponding hydrocarbon. If corresponding hydrocarbon contains 6 carbon atoms, then corresponding alkane will have formula C6H14. Structural formula for given molecular formula. Structural formula for given molecular formula. Suppose we want to find out all possible structural formula for a molecular formula C6H14. Now in this molecular formula, first of all we will determine the degree of unsaturation. Degree of unsaturation, it is already in corresponding hydrocarbon form, and for 6 carbon atom the formula of corresponding alkane is C6H14. So difference of hydrogen atom in corresponding alkane and corresponding hydrocarbon is 0. Half of this difference is also 0. So degree of unsaturation in this compound is 0 degree. It means there are only single bonds in the structural formula for structure of organic compound having this molecular formula. Only single bonds in this structure, no multiple bonds, no rings. How we came to know? Because degree of unsaturation in this compound is 0 degree, and 0 degree unsaturation means only single bonds, no multiple bonds and no rings. So now we have to draw all possible structural formula. Now always start with longest chain of carbon atom, longest possible chain of carbon atom. So here there are total 6 carbon atom. So the first structure can have a longest chain of 6 carbon atom. Now in next case we will draw chain with 1 carbon atom less, a chain with length 1 carbon atom shorter than previous chain. So let's start with the longest possible continuous chain of carbon atom and then start decreasing the length of this chain one by one. So in this case we have a chain of 5 carbon atom and now we left with 1 carbon atom. That carbon atom will be placed as CH3 side chain on this structure. So to place that CH3 side chain, now we have two options. Either I can place this side chain on this second carbon atom or it can be placed on this third carbon atom. In next category, we will further reduce the length of chain and now we left with 2 carbon atom. These 2 carbon atoms can be placed as a 2 side chain. So first I will place one of them and then we will plan different positions for the second side chain. So now to place second side chain we have 2 positions. So this is the first possibility and this is the second possibility. So for this molecular formula 1, 2, 3, 4, 5. 5 possibilities are there. The 5 structural formulas are possible. By placing hydrogen atom, you can complete their valencies or just you can keep them naked. So 5 structural formulas are possible for this molecular formula. So in this way we can also try one more example. Suppose we have C7H16. So for C7H16, degree of unsaturation is again 0 degree. So there is no multiple bond or no ring in the structure of this compound. Now we can draw first structure having a longest chain of 7 carbon atom. In next structure, the longest chain contains 6 carbon atom and one of the carbon atom will be placed as side chain, CH3 side chain. So the CH3 side chain can be placed on these 2 positions, either on one of these 2 positions or one of these 2 positions, because it has 2 types of hydrogen atoms. So this is the first structure, this is second structure, this is third structure. In fourth structure, we will keep length of chain of 5 carbon atom. And now we left with 2 carbon atom. So these two carbon atom can be placed as a one side chain containing two carbon atoms, or we can place them as two side chain each having one carbon atom, like this and this. In this way. In this way. And there is one more possibility. In this. So total 8 structural formulas are possible for C7H16. Now take one more example. It is C5H10 and we have to draw all possible structural formula for this compound. So in C5H10, degree of unsaturation is 1 degree. It is already in the form of hydrocarbon and now convert it to the corresponding alkane. An alkane of 5 carbon atom contain 12 hydrogen atoms, C5H12. So difference of hydrogen atom of corresponding alkane and corresponding hydrocarbon is of 2 and half of this 2 is 1. So in this compound there is a 1 degree of unsaturation. So either 1 double bond or one ring in the structure of this compound. In the structure of compound having molecular formula C5H10, either there is one double bond or one ring. We have to make one of them. So first we are trying to draw the structure having one carbon-carbon double bond. So always start from longest possible chain. Here there are 5 carbon atoms, so longest possible chain is of 5 carbon atoms. And now we have to place a double bond in this chain. So that double bond can be placed either on any one of these two positions or it can be placed on any one of these two positions. So if I am placing double bond here or here, so this is the first one and this is second one. In next case, the length of chain become of 4 carbon atom and one of the carbon will be placed as side chain. And now we have to place the double bond in this skeleton. So it can be placed either on this position or on this position or on this position. These two positions are identical. So if I am placing double bond here, so this is the third structure This is fourth structure. And this is fifth structure. Now, to draw the next structure, if we are drawing a chain of 3 carbon atoms, then remaining 2 carbon atoms will be placed as side chain. But now we can't draw double bond in this structure. So this structure is not possible. Because you can't draw double bond in this skeleton. Carbon is tetravalent. So this carbon has already formed 4 bonds. Now you can't draw one more bond around this carbon atom. So all these are the structures having one carbon-carbon double bond. And then we will draw the structure having one ring. And here ring is made up of only carbon atom, because a polyvalent atom can be a part of ring. Polyvalent atom can participate in ring formation. And here there is only one type of polyvalent atom, and that is carbon. So draw this structure having one ring. Always start from largest size of ring, largest possible size of ring. But also remember that organic compounds having 5 or 6 member ring are quite stable. Other organic compounds are also stable with smaller size ring and larger size ring. But 5 and 6 membered ring containing organic compounds are comparatively more stable. So now start with the first structure having a ring of 5 carbon atoms. So CH2, 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 CH2 and CH2. This is a cyclic compound called as cycloalkane. So this is cyclopentane. Now in next case, now I am drawing only bond line formula. Okay. Either you can draw this or you can draw bond line formula for this one. So in next structure we will make a cyclobutane ring. The ring having 4 carbon atom, and the remaining carbon will be placed as a side chain in this cyclobutane ring. So to place that remaining carbon atom, we have only one position. In next, we can reduce the size of ring by one more carbon atom. And now we left with 2 carbon atoms. These 2 carbon atoms has to be placed as side chain. So first possibility is place one side chain having 2 carbon atoms. And in next case, we can place 2 side chain, each having 2 carbon atoms. Now 1 carbon atom, 2 side chain, each having 1 carbon atom. So this is the first possibility, and this is second possibility. So for this molecular formula, all these are the open chain structures and these are the closed chain structures. So this is the advantage of knowing degree of unsaturation. Suppose C4H6 H6 is given as a molecular formula, and we have to identify all possible structural formula for this molecular formula. So first of all, we have to determine degree of unsaturation in this compound. And degree of unsaturation in this compound is, it is already in the hydrocarbon form. And now we have to convert it to the corresponding alkane. And the formula for an alkane having 4 carbon atom is C4H10. So difference of hydrogen atom is 10 minus 6, that is 4, divided by 2 is 2. So 4 by 2 is equals to 2. So degree of unsaturation in this compound is 2 degree. So what are the possibilities? Either one triple bond or two double bonds or two rings or one ring plus one double bond. So all these 4 type of structures are possible for this molecular formula. So let's start with the structure having triple bond. So for that we need to draw a chain of 4 carbon atom, and now place triple bond in this chain of 4 carbon atom. So there are 2 positions. It can be here or it can be here. Now to draw 2 double bond, in first possibility, this is the first double bond, and second double bond can be drawn here, either here or there. Here if we make this type of skeleton for 4 carbon atom, then we can't draw 2 double. So that's why this type of skeleton is not possible. Then we have to draw 2 rings. These are the 2 rings. Then we have to draw 1 ring and 1 double bond. One ring and 1 double bond. We can reduce the size of ring by 1 carbon atom. Okay, let's start in this way. This is the remaining carbon atom, and now we have to place a double bond. So this double bond can be placed either here, LCS2. It can be placed here, and it can be placed here. So for this molecular formula, we can draw these possible structural formulas. Suppose we have C3H6O. So degree of unsaturation in this compound is, corresponding hydrocarbon is C3H6, and an alkane of 3 carbon atom will contain 8 hydrogen atom. So difference of hydrogen atom is 8 minus 6. Half of this difference is 1. So there is 1 degree of unsaturation. So we can draw different type of structures. Structure having 1 double bond. And remember, double bond can be carbon-carbon double bond or carbon-oxygen double bond. Second type of structure, having 1 ring, and ring can be homocyclic or heterocyclic. Heterocyclic means one of the atom of ring is other than carbon atom. Like in all these cyclic compounds, ring is homocyclic ring. All are the homocyclic organic compounds. When one of the atom of ring is other than carbon, such compounds are called as heterocyclic compound. So this is heterocyclic compound. This is heterocyclic compound. So these are heterocyclic compound. When one of the atom of ring is other than carbon, we call them as heterocyclic organic compounds. So now we have to draw the structures having 1 double bond. Let's start with carbon-carbon double bond. So now when we make carbon-carbon double bond, then the single oxygen atom will be placed either as an alcohol, ROH, or as an ether with 1 double bond. So as an alcohol we can draw this structure, because in alcohol OH group is always bonded to sp3 hybridized carbon atom. And in ether, this is a possibility. For carbon-oxygen double bond, it can be an aldehyde or it can be a ketone. So there are total 3 carbon atoms. So for 3 carbon atom, it can be either of this aldehyde or this type of ketone. Thus we have to place hydrogen atoms to complete the valencies of these carbon atoms. So all are these structures having 1 double bond. We can't draw more structures, because when you place OH group on this carbon atom or on this carbon atom, we call them as enols. and enols are not counted in total number of structures. Remember? Not considered in total number of structural formulas. Remember that enols are not counted in total number of structural formulas, in total number of structural isomers of a compound. And enols are organic compounds in which OH group is directly bonded to double bonded carbon atom. OH group is directly bonded to double bonded carbon atom. Now we have to draw the structures having one ring. Ring can be homocyclic ring or it can be heterocyclic ring. So let's try first homocyclic ring. So homocyclic ring is of 3 members because we have only 3 carbon atoms. And now one of the oxygen left will be placed as an alcoholic functional group. So only one structure is possible for homocyclic ring. Now for heterocyclic ring, total atom in this case can become 4, including oxygen. So largest size of ring possible is of 4 members. This is cyclic ether. Now to draw the other structures, we can reduce the size of ring by 1 carbon atom, and that carbon atom can be placed as a side chain, CS3 side chain. So this is the homocyclic compound and these two are the heterocyclic compound. So for this molecular formula, 1, 2, 3, 4, 5, 6, 7 structures are possible. Suppose we have one more structure, C9 H12. And draw structures having one benzene ring. When we determine degree of unsaturation in this compound, then it comes out to be, it is already in the form of hydrocarbon, and alkane of 9 carbon atom contains 20 hydrogen atoms, C9H20. Difference of hydrogen atom in alkane and hydrocarbon is 20 minus 12 by 2. 20 minus 12 is 8. And 8 by 2 is equals to 4. So this compound contains 4 degree of unsaturation. So degree of unsaturation is equals to 4. So this compound can have a benzene type ring. And it is already instructed that we have to draw these structures having one benzene ring. So this is the benzene ring. And now we have to place the remaining 3 carbon atoms. So these remaining 3 carbon atoms can be placed as side chain having 3 carbon atoms. If a side chain contains 3 or more number of carbon atoms, then it can be placed in more than one ways to a skeleton of carbon atom. Now we can place 2 side chain, one containing 2 carbon atom and other containing 1 carbon atom. And for 2 side chain, we have 3 positions: ortho, meta, and para positions. These 2 are called as monosubstituted benzene, and these 3 are called as disubstituted benzene. Now we have to place 3 side chain. This is the first possibility, to place 3 side chains. This is the second possibility for structure with 3 side chain. Now one more structure can be drawn. So for this molecular formula, these many structures are possible having benzene ring for 4 degree of unsaturation. We can also draw some other structures, but as per the instruction given in question, we have to draw these structures having one benzene ring. So 8 structures are possible. For example, we have dimethyl cyclohexane. Dimethyl cyclohexane means, dimethyl means there are 2 CH3 group. Or 2 CH3 side chain. Cyclo means ring. Hex means having 6 carbon atoms. And this N means only carbon-carbon single bonds. So we have to draw possible structures of dimethyl cyclohexane. Means we have to form a ring of 6 carbon atom with only carbon-carbon single bond. And then we have to place 2 CH3 groups on that ring. So this is the cyclohexane ring. And now we have to place 2 CH3 side chain on this cyclohexane ring. This is the first possibility. This is second possibility. This is third possibility. And this is fourth possibility. So these are the concepts or ways to draw all possible structural formula for a given molecular form. So you must try to draw some more structures. I will upload some assignment. So it's all about for today's lecture. Thank you.